Today we will discuss Hurwitz polynomial. Now, if PS is Hurwitz polynomial, then PS is real if S is real. 2. Real part of PS is 0 or negative. So, if we draw a number plane and then all the roots of PS will lie on this side or on here. This is the imaginary axis. We say, let's say, or better, real part of S, and this is imaginary part of S. So now if you want to see some example of Hurwitz polynomial, let's take for instance S cube plus 2s square plus s plus 1. And make this a little loudest. S cube plus 2s square plus s plus 1. First check that all the powers are present. 1. All powers of s must be there. Okay, number 2. All coefficients must be positive. Now, there is an exception to this rule. If all powers are not there, then either even or odd, all even or all odd powers of S must be present. First of all, if we take this example, we see that all the powers of S are present. So we divide this into two parts, an even polynomial E and an odd polynomial O. So ES will be 2s square plus 1. The odd part will be s cube plus s. Now what we have to do is test ES by OS. Now as ES has one power less than O, we will not test this, we will test OS by ES. Or either way you can test ES by OS, and what we have to do is, the most important thing is all residues must be positive. So let us try to do this. So what we do is, we divide s cube plus s by 2s square plus 1. Now we place half s, that becomes s cube plus half s. We are left with half s. Now next, we just copy this to here. That becomes Now what we do is multiply by 4 and s, that becomes 2s square. Now this is 1. Next we do is put this in here, and this become half s, and this cancels out. So we see this is positive, this is positive, and this is positive. Now we can state that this given polynomial, let's say PS, is Hurwitz polynomial. Now let's take another example, a similar type. Start from this end. Let's take PS is equal to s to the power 4 plus s cube plus 2s square plus 3s plus 2. We make the even polynomial and an odd polynomial. The even part will be s to the power 4 plus 2s square plus 2. The odd part will be s cube plus 3s. Now again we see that even polynomial is a higher degree than the odd polynomial, so we test ES by OS. So for doing this, we start over here, s cube plus 3s s to the power 4 plus 2s square plus 2. So this becomes s to the power 4 plus 3s square. Minus s square plus 2. Next we do is this. We write this one over here, s cube plus 3s. And this become s minus s. That is s cube minus 2s. We will not proceed anymore. Why? Because we see here this one is negative. From here we can directly say that this is not Hurwitz polynomial. Next, we will take another example. Let's try a function PS equal to s to the power 4 s square 3s square plus 2. Well, here the event polynomial will be s to the power 4 3s square plus 2. Odd polynomial will be 0. So how will we proceed in this case? What we do is we find another polynomial, let's say p1 equals to derivative of p. So this become 4s cube plus 6s. Now we will use this 2. We will test for p by p1 for positive residues. Now let's start. 4s cube plus 6s, and we will divide s to the power 4 plus 3s square plus 2. This is p, and we are dividing it by its derivative. So we get 1/4 s. This becomes s to the power 4. This becomes 6/4. That's 3/2 s square. Subtract. Now this is 3/2 s square plus 2. We will write this over here. 4s cube plus 6s. Now this becomes by 3 s, and this is 8. 3 3 8/2 4. 4s cube plus 8 into 2 16/3 s. What do we get? Subtract this, cut this off. I'm using my calculator for many. Two by 3 s. Here we will write this one, 3/2 s square plus 2. So here for dividing we'll write by 4, and this is 9, and s. 3/2 s square. Subtracting, we have 2. Now we take the remainder division here, 2, and we will just put this one here, 2/3s. This become 1/3s. That's 2/3. Now we will check first that this one is positive, this one is positive too, this is positive, and this is positive. So this is a Hurwitz polynomial. That's all. And next, the uses of Hurwitz polynomial. 1. It can be used to test if a polynomial PS has positive roots. As we know, anything lying on RHS will make the system unstable. This is what we can say is whatever is here unstable. If there are roots on the imaginary axis and they are simple, the system is marginally stable. And if the roots are on here, whatever, on this side, the left side of the plane, this is stable. So if PS has positive root, it will lie on a right hand plane and the system will be unstable. So if a polynomial is Hurwitz polynomial, its root will lie on left half of the plane. This proves the system will be either stable or marginally stable. Now further test will be required to test if the conjugate roots are repeated or not. That's a different question. So we can say that with using Hurwitz polynomial, we can test that a system is stable or not, and its root, and if it has a root on positive side or right hand side. The second will be, it is used in testing positive real function. Actually, the previously discussed property, that positive root, that's been used in testing PRF. That's the first step. If you want to test for function for PRF, test the given polynomial PS must be Hurwitz. It is generally the PRF have further application in synthesis of RL network, LC network, or RC network. Okay, that's all. Thank you for watching and have a great day.